Welcome back for a live bonus episode here, C++ live code with a core image format. I'm a little bit curious, how much smaller can we get photorealistic images when we lossy compresses? So Koi is not designed for lossy compression, but we can of course just discard some precision manually. Let's maybe add here a bool lossy, just for a test if compression is equal lossy. I think I should compile. Thankfully we have this infrastructure in exact image already for additional compression arguments. So let's read output, so compress lossy. This was a typo. Compress. So we also need to implement this, so lossy. So this constant compiler has it easier to optimize. So idea would be we have here an operator. All right, we can't directly. Okay, let's copy that. So much to operator overloading, then you can't do fancy tricks there. Let's call this similar. It's of course not ideal. Basically with bool lossy. Okay, doesn't matter, lossy. So, and the idea would be to if lossy we could actually compute the differences again. Welcome everyone. dr equals finally finished titanium experiments. I can listen to the stream without being distracted from the fan noise. Happy to hear that. Hope you have good results there. Oops. So differences RGBA, 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 and then return dr0 dr G. What does Apple Silicon help you when it tortures you with keyboard layouts? RGB. And so that doesn't change a thing yet. So that is equal. So we change that to similar pixel L pixel. We can even use this here as a histogram. The only thing is we probably should change, or should we? I mean, we obviously increase some errors, so we later would want, if we would want to put this to production, not sure if we want change that to carefully storing the actual value. Similar, also best without typo. English skills. Good. So here index, and also for the delta and coding. So the only thing is we probably, because the error accumulates, so we could drift quite away from the actual value. So we should actually change the code also to actually continue working with actually, wait a second, does it drift away here? We have used the index, or actually here it should not yet drift away, but if we use the other data encodings where we actually store the actual value, we should actually update our pixel. So let's see, does it build, does it do something? So now, all right, we need a lossy to only optionally do that. And theoretically, if the results are promising, we could change that to use some kind of dithering to hide the error a little bit, to dither the error, that it's even less visible. So basically we want to, if not lossy, then return that. Otherwise, otherwise a little bit more stuff, namely probably so this can be negative, the differences here. So return abs from absolute value from dr less than, say, 2. Could of course make this configurable, maybe like const max d, so equals 2. Keyboard is killing me. Don't get Apple hardware. That do we get this all RGB? So abs DA R G B before similar, one more closing parenthesis there. So is it smaller? That is a question. So we have here 726. So this is how easy you can, with a simple trick. 728, 728, 987. Yeah, so it's a tiny little bit smaller, and so what we do here is we run length compresses even if it's similar. So this is how quickly, it's of course how quickly you can turn an otherwise specified as lossless format into a lossy format. Just quantize that to some similar values. Certainly if we increase that further, we could even, like if we just change that to 4, then maybe gets this already even smaller. I mean, not the most, but we can also add this to the other deordering step. We could scan the whole histogram, so currently it is hashing. Let me. So so currently they are hashing the histogram. We could always, I mean, it's a significant increase in compression time, but we could scan the histogram, at least either the surrounding values or all values for similar values, and of course change the delta encoding here as well, so that for example here simply if lossy, then for example like half those dr, simply divide those by 2 as an example, or more, depending how lossy you want that. So you could have lossy factor RGBA. So the only thing is that we could have quite some color runaway shift here as we continue distributing the errors, so we should actually update the actual value. So let's first see if that works. Yeah, so that's what I thought. Is that it looks interesting though. Nice. This is also how you can create visual effects for Hollywood movies. Yeah, it is significantly smaller though. I think it went down from 700 something. Yeah, so 200K like that. And I think if we would update that, here, if basically DRG, this of course is very significant improvement if we could make this work correctly. So we're patching this to add lossy compression. Well, on my own code, right? I'm not working on their one header C reference code. I re-implemented this in C++ and try how much smaller we can get this with adding some lossy factor. So, so basically, if lossy, then update the if lossy, because we modified this lossy, then update our new effective pixel value to pixel equals last pixel, or yeah, either this and pixel are US layout delta red. Wait a second, no, actually we should actually update all RGBA, so update plus the delta of delta RGBA. Theoretically a vector, single instruction multiplier vector stuff could come to the rescue. I know this still causes significant bending. Why? If lossy updates the pixel value, why does this happen? So with that, only here we update the last that is at times. What I, by the way, sometimes do to shorten that. So if this would be a vector, we could divide the whole thing. I'm not the most picky with like stressing the line code stuff. If this is all divided by 2, then for readability, D, G, D, B, D, A. Actually, we could, maybe it would be, you know what? Maybe it would actually be better. Actually, we lose here quite some precision. Actually, I think it would be better if we use here different, if we clamp that. I think this could lead to better results. Is this maybe the reason also? Also, you know what? Why this might happen? Maybe this happens because this overflows. And then it doesn't overflow. Maybe this is why this... so actually, maybe we actually should check if that, because this relies, for example, this might be dark black, dark gray, and it should overflow to bright white. And then we cast here this overflow way. This is of course worst case. So basically, we should actually do here some additional thing of if that is not an overflow. So yeah, it's a little bit more tricky than but that's often the thing. You think, it's super easy, just add this, but yeah, the devil is in the details. This is probably how this happens. But yeah, if you need some nice effects for your Hollywood movie thing, then you can also distort it like that and make some expands like so Star Trek, Star Wars like effect thing. So what we could do if we wanted to do that, we could use because the problem is always how to do this efficiently except using some CPU like overflow flag. We could of course check if explicitly checks this in C if this is an overflow. We could also, which is a little bit ugly looking in C, we could also simply compute the differences as 16-bit, like 1 next magnitude larger. And yeah, and check that it shouldn't overflow like this. So this was a little bit tiny, a little bit smaller. I mean, theoretically, we could commit that theoretically. Let's see how large test suite. What was the other codem? And this is codem 10. That is only getting very smaller. So just similar histogram. Yeah, so we would need to do this delta thing here as well. Should we do this one proof of concept? Maybe we should. Fast production mostly depends on what you're saying. Language you use specifically. Fast. What do you mean with fast production? It depends. I use for automating Unix building stuff, shell scripting, for high performance code still C++, for application logic Lua. It's actually somewhat popular choices, I would actually say. So if let's maybe quickly check if we can make 16. Should that work naturally, or maybe we need to cast that first? Otherwise, there's always the tricky details whether it could be that this is otherwise done in that type. And then, so basically, that would mean so the difference should not be negative. That would be overflow. I mean, obviously, if the difference is, oh, wait a second. Oh, no, it isn't. Wait a second. Can we even reliably? Wait a second. If we have, actually, this is not that easy. You know about find name, make GitHub. What you saying? GitHub what? Enter GitHub. Enter. No. Run the virtual commands when file changes. Cool. Yeah, previously I used Emacs here build, but this somehow I think doesn't also theoretically this like 20 years ago. But yeah, obviously Emacs is a very bit rotten editor. No release in 10 or 15 years. Yeah. So yeah, signed 16 doesn't really help us much here because if we compute in overflow, this is still just -1, for example, to overflow from 0 to 255. So I guess we would explicitly need to check overflow. That is a little bit annoying. Actually, a little bit of an understatement. So yeah, this makes this a little bit more complicated, unfortunately. I wish so. Yeah. So this is also, I mean, yeah, not that you would need this every day, but somehow that this kind of stuff is not significantly easier already. Where were we? So that is a little bit. Yeah. So basically, it's actually relatively annoying to type here, then integrate into that. Welcome everyone. Yeah, so this would be cool if that would be somehow easier. But so basically, what we would want is if this is not basically twice as much. So we could basically set this, I mean, right now we could further mess this up for testing. So const, what do we have there? Does it matter? Nah. S8 dmax equals 2. And I have this now to better save. Okay, apparently let's also use Lena. I don't know where's this copyright, or I think maybe it's from Wikipedia. And basically fuzzy, lossy, yeah. Lossy 4.2. Only need to check for overflow though, which is a really tricky part. Which is, yes, so I mean, this is actually really tricky. Maybe it would be better to make an extra conditional for if fuzzy and then that, because we would still want the regular overflow capable version of that. Ah, darn. So basically, getting a bit ugly. I don't like to open code this stuff. This would be somehow need to go into some generic. So basically, fuzzy, lossy. If lossy and two times that and I mean, theoretically, maybe it's easier to pre-process that actually to if fuzzy and like not to open code this conditional here like that, because we would need so all of this plus no overflow. Okay, maybe this is, but yeah, this is also the process of developing, right? I mean, especially this like, yeah, research, and obviously this is one of the easier things. I mean, we could, how do we do this easiest? The thing is, I'm looking for an readable and like easy solution to hack. Something is always the easier thing, but coming to some more generic solution, we could like compute the differences and then like if I mean, basically we have the difference, and basically if the last pixel plus the difference is greater 0 and We would need a type that basically, maybe we want not, basically we could make a function overflow if not overflow pixel r dr. Also, we anyway want dA equals c, or actually we could even do that for similar delta A values. If not overflow that, not overflow that, and not overflow that, so A, R, G, B. Okay, let's maybe sort this. All right, I had one more. I just only moved this in the name of. So if those do not overflow, we need to write the function in a second. Then limit this deltas. Basically, it's getting a little bit complex. So did I still lift this up? So there we have it. So if those don't overflow and the value is, I mean, the only thing is that this is that is asymmetrically biased, a little bit annoying. I mean, we could for a, not for, by the way, could we, should we check that first, maybe? Overflow GP. Oh, so wait a second, then substitute GP. I mean, for a test, we could have that again, and just for test, theoretically, we maybe I think clamping that might, or does it? No, I'm not sure. Actually, the format could have already defined the format could actually have defined that as this deltas as a power of 2 or something with a little bit lossy. RGB, oops, A, oops, hello, where's my focus? So these are both, so this is, pixel is U8 and S8. So that is U8. Let's maybe let it cast it already, promotes it to sine 16 for our overflow check. And we had sine 8, 4 and delta. And return 4 minus d less than 0 or 4. Oh, wait a second. This is the sign. So we want if that is less than 0 or plus d is greater. That's a little bit open coded for tests. Theoretically, we could use a template and auto generate those. Cannot be used as a function of. Maybe we didn't define one of the correlation overflow with no type of 16. RGBA. Did IR didn't boost an overflow. Did I do this lossy? We did this lossy. So, did this do any 716? Oops. So it still looks visually, I mean, so for this we would need to diff the images to see the difference, either with pure mathematical difference or perceptual difference. So how much smaller is it, if it even works? So that is 728, and with lossy that is, so it is a little bit smaller, not as much as I would have hoped. Although we could, for example, just like divide by 4 because precision. Still looks okay-ish. 716, what did we have before? Again, clamp, although might clamping, not sure if, do we see any bending yet? 716, is it not getting, what do we do here? If all of those do not overflow, then actually I would have expected that to be more visually. I wonder if is the compiler clever enough to. Maybe we should write it like that for better constants. Actually, I'm surprised that this doesn't change more. we do something obviously wrong. 76909. I mean, wait a second. So also we should fuzzy, obviously, lossy, and not overflow, RGB. Maybe this overflow, we should actually test that, like nothing like a unit test for this stuff. I have the feeling something is not working there. So 728. Some of this. I have a feeling something is not working there. And so that is always, of course, debugging this. If the time-consuming part, here's our if signed 16, if that overflows, if that, or I think this should be okay. Yeah, if you see some bug, if you want to debug on this, let me in the comments below. But this is basically, we already get some improvements, not yet as much as I would have hoped for. We could even, as this other similar, where is that? Oh, we have somewhere if you already max difference of like 8. Because eventually we should see more of a change in the image data. Or actually, theoretically, we should rather... I know it's significantly smaller. I mean, significantly 679. But yeah, so with that similar, with these simple things, already quite some savings. We could, of course, we will probably not see that, so we can extract images test with original for something TIFF. But we will most likely not visually, or do we? Yeah, we would need to diff that. But yeah, they also see, I don't see a difference here, even on my display before the YouTube video compression. I wonder if I should commit it like that. Maybe I leave it here just for the sake of that. Yeah, so the delta stuff, it could still be significantly improved. We could also this code thing for... Do we have lossy somewhere? Oh, that does not yet quite work. Interesting. So, okay, this is just these differences. Yeah, I think, okay, you see there's some, at least I think that are some stripes layer, probably not in this. So it's probably like this runs with, doing this runs with a similar color that runs so long, I would say. Most likely. Probably should be still improvable, especially with dithering, and certainly not as high of a difference. I only wanted to do that for testing. I I think it's quite a bit smaller though. I'm not, oh, wait a second, not, oh wait, this is also, yeah, so 200K. Of course, this does not look amazing, but this is only proof of concept, so it is possible if you wanted to have a little bit lossy factor there to improve that a bit better. If you wanted to, for example, here, if you leave this as 4, yeah, so that immediately looks significantly better, and the size is, yeah, obviously in the middle. And if you implemented the delta encodings so in a way that they actually work, the overflow checking there, a little bit tedious. But yeah, that's how you do some image processing, programming, and research. Hope you enjoyed this additional bonus material. I'll go finish some other stuff. I hope you learned something, and to see you soon for all the next videos and live streams to come.